divided into 4 or 5 programs. So most of, if I see that some 70 to 80% of the program is common, so then I can take that common program outside a particular case, and then I can define the case structure, and then I can put keep on generating a case after case, so that what happens, it will save my time, it will save the space, and also it will helps you for your programming speed. Okay, so let's go to the file, select a new VI. Okay, so now this new VI is been generated, press Ctrl E. Okay, so before that, I will like you to understand that what is a signal processing, how we can actually generate a signal. Okay, so in this case, I will explain that how to make a sinusoidal signal with a variable amplitude, with a you can say a variable frequency. Okay, so a waveform generation, a signal generation is one point, then signal condition is the second point, and then signal operation is the third point. So generation of a waveform, conditioning of that particular waveform, and then operating on that waveform. These are the 3 steps of a signal processing. Okay, we need to understand that can we draw a basic waveforms, and then can we see the properties. Then I will help you by drawing a particular case. Okay, so now just try to make a function generator on your laptop or desktop screen. Now have seen a one function generator, or basically some DSOs. So how does that look like? You have a one screen, you have a certain knobs. Okay, you changes the amplitude, you change the frequencies, and automatically on the DSO you see that your sinusoidal you have generated from a function generator is being displayed on the DSO, variable amplitude, variable frequencies. So right now I will explain you how to make a function generator and DSO combination. A function generator means all the knobs that you have in a function generator you will have over here, and then the signal you put it on the DSO. That also is possible. You connect to an hardware, and then you can have a that particular output to in hardware. So most of the time, like your PC has some limitations, your PC processor has some limitation, it can easily accept several hertz of the frequency, it can give it to an external hardware, but not several kilohertz of the frequencies. So if your system operates at several kilohertz, then you need those specific hardwares. But as far as the simple programs are concerned, that you can use the processor of your PC, that's I think it's a well built for several kilohertz of the frequency to several hundred of the amplitude. Okay, first I will do one thing. I will create a waveform chart. Okay, in this case, create a waveform chart. Okay, just put a waveform chart in the second half. Okay, okay, so waveform chart we have created. Now I will create a certain amplitude knobs. Right click, go to numeric, select a knob. Knob you will find the third row from the bottom, and first column. Just drag and drop a knob, put it somewhere here. Okay, you expand it. See, just like an DSO knob, you can change the orientation of this particular knob. So this is a one knob. I can write it here as a frequency knob. Okay, now I want to scale it. Let's make it 0 to 100. So what you will do, on 10, double click on 10, type 100. Now knob automatically changes its orientation from 0 to 100. Okay, so we have a one knob that has a scale from 0 to 100. Now I will create another knob. Go to numeric, select a knob, put it over here, write down amplitude as its name, little bit increase the size, and type 100 instead of 10. Okay, so now I have two knobs, amplitude and a frequency. Okay, now I can create a waveform. So it should be a waveform of your choice, a waveform of your choice with a variable amplitude and variable frequency. Now press Ctrl E. Now we have created a two controls, frequency knob, amplitude knob. These are two are controls and one indicator, that's a waveform chart. Okay, press Ctrl E. You obtain these three things, two controls and one indicator in your block diagram. Now right click, and now we will start using a signal processing block. What is a signal processing block? Now अभी हम इन सब में से कुछ यूज नहीं करेंगे, मतलब इनका भी यूज रहेगा लेकिन कम रहेगा, जैसे एडिशन सब्ट्रैक्शन उस तरह की चीजों में. We will go to signal processing. You can see here signal processing. So ये सारे लाइब्रेरी फंक्शन जो आइकन्स वाले हैं इनको हटाकर मेजरमेंट आयो, इंस्ट्रूमेंट आयो, मैथमेटिक्स एंड देन सिग्नल प्रोसेसिंग library is there. You need to go to that signal processing library, and in that signal processing library, okay, go to waveform generation, first one case here, WFM generation. Okay, signal processing में WFM waveform generation, first row first column में आपको waveform generation मिलेगा. Okay, now this waveform generation is there. Now in this waveform generation you can see so many inbuilt waveforms are there, like a basic function generator is there, tones and noises, all sorts of tones and noises you can make. A formula waveform, you can put in simulation equation and automatically that formula will be generated. A sine waveform, square waveform, triangle waveform, sawtooth waveform, a multi-tone waveform, multiple amplitudes waveform, multi-tone generations are there. Then these lines are for the noises. There's a uniform white noise waveform, then there's a Gaussian white noise waveform. PRN represents a periodic random noise waveform, and INVF, that's the inverse frequency noise waveform. So there's a different sorts of noises also, and we can have these noises waveform. Then gamma waveform, Poisson waveform, binomial, Bernoulli's MLS waveform. This is a sequence waveform. Simulate signal, simulate arbitrary signal. So these functions are there. Okay, now just drag and drop this simulate signal. Last में आपको एक simulate signal दिखेगा. Okay, this simulate signal. Just put it in the last. You can see this simulate signal. इसको drag and drop and put it on your front block diagram. Automatically one window will pop up. Okay, it shows that a signal type is sine, स्क्वायर, ट्रायंगल, सॉटूथ, डीसी. तो हम इसमें से सिलेक्ट कर सकते हैं. ये साइन वेवफॉर्म पे सिलेक्ट करेंगे. जिसका फ्रीक्वेंसी है, एम्पलीट्यूड है, ऑलरेडी गिवन है. 10.1 फ्रीक्वेंसी है और 1 एम्पलीट्यूड है. ओके, बट आई हैव अ फ्रीक्वेंसी एंड एम्पलीट्यूड नॉब सेपरेटली क्रिएटेड. सो दिस फ्रीक्वेंसी एंड एम्पलीट्यूड आई कैन चेंज. Add noise. If you want to add noise, then these features are there. Timing, see that samples, 1000 samples per second, 100 samples. Okay, I press OK. So this simulate sine waveform is generated over here. Now drag it from the bottom. इसको नीचे से आप drag कीजिए. Okay. Now you see that there are certain inputs like amplitude, error, frequency, offset, phase. Just give an amplitude. Connect an amplitude to the amplitude. Connect a frequency to the frequency. So connecting an amplitude to the amplitude, connecting a frequency to the frequency, and what's its output? Its output is sine. First row पे आप देखिए साइन लिखा हुआ है. ये साइन का आउटपुट डायरेक्टली इस वेवफॉर्म चार्ट को दे दीजिए. Okay, so this is the program. So see that simulate sine signal. Simulate sine signal, how to find it? Right click, go to signal processing. In signal processing, first element, waveform generation. In waveform generation, last element, last row, simulate signal. Okay, just drag and drop and put it here. Now connect a frequency and amplitude knob like this. Now I can put this program inside a loop. So go to structures, select a while loop. Now this is done. This program has put inside a loop. Now I need to create a stop button. So I will move my cursor to this loop condition, right click, create a control. A stop button is being created. Now I can create a delay, right click, go to timing, and you can select some delay, wait milliseconds. So I select a wait milliseconds. Here, move your cursor, right click, create a constant. Type here, maybe you can type 300 milliseconds. Okay, so this is the program. Now press Control E. Press Control E and try to run this program. Okay. See that you get a flat line. Okay, this is a program is bit slow. So I need to reduce the delay to 200 millisecond. Now I run this program. See that you get a flat line. Why? Because amplitude and frequency both are zero. We set the amplitude and frequency at zero. Slightly increase the amplitude. See that amplitude has increased, and slightly try to increase the frequency. Now you see that a sinusoidal is being plotted up. Just reduce the frequency. See, a sine waveform is being plotted up. Now increase the frequency. See, this is 100 hertz frequency. Okay, you can't see anything. It's a very complete, very fast. Now you reduce the frequency. Slowly you will start observing the signal. The frequency is around 10, so it's observable. The frequency is around 3. It's nearly 1. Okay, see the amplitude variation. Amplitude is very high. Amplitude is low. So amplitude variations also works very properly. Okay. You see here the amplitude variation of this particular case. Okay, so this is the basic signal generator that we can use, and we can write our hardware with this particular sort of signals. So we have an inbuilt sine, square, sawtooth, ramp, triangular signal. Okay, so many noises are there, and we can run it to a particular hardware waveform, and we can see the change. If like you want to see the change, you can easily see it. Okay, you want to see the block diagram, press Control E. See, this is the block diagram. Frequency, amplitude, two knobs, a simulate signal, okay, and a waveform chart. Nothing. This loop, this delay is always common. So this thing is there. So I just wanted to explain that how this simulate signal is being operated. Okay, now next case. I stop this program. There's a stop button. I stop this program. Now see, I will just delete this stimulate signal. Okay, I will use some another block now. I will keep the wiring as it is. So just I select this block and I delete this. Delete this wires also. No broken wire should be there. If there is a broken wire, the program always gives you error that there is a broken wire. Okay, now go to signal processing. Okay, we go to signal processing. In signal processing, we go to waveform generation. In signal processing, we go to waveform generation. In waveform generation, we go to basic function generator. Okay, so how to do that? First, we go to signal processing. In that first element is waveform generation. In this first element, waveform generation, this is basic function generator. Select this. क्या लेना है आपको? Basic function generator. Okay. So signal processing first element waveform generation. In that first element is basic function generator. It's very easy to find. Now Once you obtain this basic function generator, now see its property with the question mark. What does it say? See, it says that there's a reset signal, okay, signal type, frequency, amplitude, phase, all this stuffs are there. Okay, so I can connect a frequency to the frequency, I can connect an amplitude to the amplitude. That's one thing. So this is a frequency, I can connect to a frequency. Okay, I can take a knob from the amplitude, I can connect to an amplitude. So frequency and amplitude, these two we can connect, and the output is there. Signal out is the output is brown color wire. Just connect it to your waveform chart. Okay, so this particular thing is done. Okay, now important thing, this also shows a signal type. आप top पे देखेंगे तो blue color का wire है. It shows that this is a signal type. Here a blue color wire is there, signal type. Okay, so right click on that blue color wire, go to create a control. Right click on that blue color wire, go to create control. So signal type will appear. Okay, now press Ctrl E. You see that there is a signal type over here. Let's put it over there. Okay, so signal type actually shows us the toy type of waves. So see that there is a sine, triangular, square, and sawtooth. These 4 waves are there. Now I press Ctrl E. Press Ctrl E, and this is our program. Now we run this program. The sine is selected, run the sine. See that a sine wave is being selected. Now change it to square. See that a square wave is being created. You can see a square wave now. Okay. Now next, a sawtooth wave. You see that there is a sawtooth wave that is being generated. Next is a triangular wave. So this is the triangular wave now.
Hello. Madam, ते आईचं कन्फर्म केलं का?
Okay. Sir, someone's mic is on.
Vijay, Mr. Vijay, your mic is on. Mr. Vijay.
Yes. Okay, so now this is one sinusoidal signal, a triangular signal, a square signal, and a sawtooth signal. Okay, so suppose I take a square signal, I change the frequency, see the frequency variation. It's very, very fast. This is a square signal. I wanted to show amplitude variation, see that amplitude variation of the square signal. Okay, same thing applies to a triangular also. See that amplitude variation of the triangular wave, and here the frequency variation of the triangular wave. Okay, so see that a very simple program, just use a basic function generator and you are able to actually have your own function generator with a DSO. It's a real time, and once you connect to an hardware, then you can use the processing speed of your PC, how much frequency and amplitude can provide to an hardware, and you can use it for writing to a particular hardware. Okay, so this was the one case. Now let's move to the cases. So आप अभी देखेंगे कि इस पर्टिकुलर सिग्नल में जैसे ट्रायंगुलर केस था, साइन केस था, स्क्वायर, ये सब केसेस थे. Okay, someone is asking how this signal type comes. Okay, so ma'am, this signal type in this waveform function, basic function generator, see the question mark, properties, it shows that on the type, on the top right, there is a signal type. So you go to that signal type, move your cursor to signal type, right click, create a control, right click, create a control. So it automatically generates a signal type. Press Control E. The signal type is over here. Okay. And this is how we generated this signal type. So I can select a square and I can run the program. Okay. So this was the case. Now let's move to the case structures. Case structures. Okay, so can we make different cases? So now see, you understand that how we can plot. मैं कभी भी साइन सिग्नल, स्क्वायर, रेक्टेंगल, नॉइजी साइन सिग्नल ये सब बना सकता हूँ. ओके, इस तरह से मैं कोई सा भी वीफॉर्म क्रिएट कर सकता हूँ. लेकिन जब सिग्नल ऑपरेशंस की बात आती है तो लाइक सपोज मैं अगर दो वीफॉर्म जनरेट करता हूँ, साइन वीफॉर्म और स्क्वायर वीफॉर्म. ओके, और इन वीफॉर्म के साथ मुझे कुछ ऑपरेशन करना है, जैसे कि मुझे अगर इन दोनों का कन्वोल्यूशन करना है. ओके, जैसे मुझे इन दोनों वेवफॉर्म को मल्टीप्लाई करना है, इनका फूरियर ट्रांसफॉर्म निकालना है. So then I can't create that much waveform charts and graphs because there is some limit. As such, like there's no limit, but it takes a lot of time. So then we can have a very well professional graphical display, and we can use a common plots for multiple programs. Okay, so for that I go to File and select New VI. Now this file and new VI, if you see that here, so basic ideology is that I will have a two knobs, frequency and amplitude. Okay, I will change the frequency and amplitude of two signals. Okay, and there is going to be a one output knob, one output display in which certain operations are going to be performed. For example, आपके पास एक साइन सिग्नल है, उसको एक फ्रीक्वेंसी और एम्पलीट्यूड दीजिए. आपके पास एक स्क्वायर सिग्नल रहेगा, उसको एक फ्रीक्वेंसी और एम्पलीट्यूड दीजिए. ठीक है, तो साइन सिग्नल और स्क्वायर सिग्नल आप जनरेट कीजिए. देन उन साइन और उस स्क्वायर सिग्नल को आप मल्टीप्लाई कीजिए, डिवाइड कीजिए, सब्ट्रैक्ट कीजिए, ऐड कीजिए, उन दोनों का कन्वोल्यूशन निकालिए. ओके, उन दोनों से रिलेटेड आपको अगर हिस्टोग्राम निकालना है वो सब आप निकाल सकते हैं. सो देयर आर मल्टीपल ऑप्शंस अवेलेबल, whichever you wanted to do. If you want to have a FFT, that is also possible. So we do like that. So program is going to be more indicators and more controls, but everything will be very simple. Okay, first create a waveform chart. Go to waveform chart, select a waveform chart. Just put it somewhere here. Right, let's give it a green color. Now color is important because we have to identify our waveforms. Okay, so waveform chart is done. Let's write it as a signal 1. Okay, so I'm doing a signal operation now. This is a signal 1. Select another waveform chart. Write it as signal 2. Okay, give it some different color. Okay, now to control signal 1 and signal 2, I will put two knobs. Okay, two knobs for signal 1, two knobs for signal 2. But as such amplitude, I don't think we require. We just put a one knobs for a frequency, one knobs. Okay, so right click, go to numeric, select a knob, one knob. Let's write it as amplitude for 1. Okay, amplitude for 1. Create another knob, write on frequency for 1. So addressing signal 1, amplitude 1, frequency 1. Now, numeric, go to another knob, select a amplitude 2, and we can select a frequency 2. So we have selected two knobs for each signal. So किसी भी सिग्नल का एम्पलीट्यूड और फ्रीक्वेंसी मैं कंट्रोल कर सकता हूँ. अभी सब कुछ फ्रंट पैनल पे चल रहा है. ओके, जो भी मैं कर रहा हूँ सब कुछ फ्रंट पैनल पे हो रहा है. नाउ राइट क्लिक, सिलेक्ट अ वी फॉर्म चार्ट. Okay, I can write it here as a output. Okay, so on the left side of my program is basically a user driven, and right side of my program is whatever results I will get over here is big screen I will get. Okay, press Control E. Press Control E now. Now you see all this stuff that whatever you have created: amplitude 1, frequency 1, amplitude 2, frequency 2, signal 1, signal 2, and output. Okay, so now we need to generate a signal 1 and signal 2. How to generate a signal 1 and signal 2? Okay, right click, go to signal processing. You go to signal processing. In signal processing, see that a waveform generation is there. Waveform generation. Okay, normally we selected a basic function generator, but here you see there is a sine waveform, there is a square waveform. Multiple options are there. Now it's totally up to you which sort of waveform you wanted to select. Okay, so how much space do I have here? I have plenty of space. Okay, so let's select the two waveform. Go to signal processing, go to waveform generation, and in this waveform generation, select a basic function generator at top. Basic function generator आपने drag and drop किया. Okay, अब एक और basic function generator select कीजिए. Go to signal processing, waveform generation, select one more basic function generator. Okay, now very simple. हमारे पास दो बेसिक फंक्शन जनरेटर है. ओके, फर्स्ट वाले का फ्रीक्वेंसी से कनेक्ट कीजिए. फर्स्ट वाले का एम्पलीट्यूड से कनेक्ट कीजिए. सेकेंड वाले का फ्रीक्वेंसी से कनेक्ट कीजिए. और सेकेंड वाले का जो एम्पलीट्यूड है वो एम्पलीट्यूड से कनेक्ट करिए. डन. Output of first basic function generator, give it to a signal 1. Output of second function generator, give it to a signal 2. So see that this is the same program I am repeating, but now I'm more interested in doing in some signal processing operation. That's why I'm generating two waveforms. Okay, now these two waveforms are done. Now what? Yeah. Now some operations need to be done. Now the question is, can I create a in this one output waveform chart? Can I have a 4, 5, 6 operation between these two signals? So that I have to create a 6 cases for that. 4 cases, 5 cases, 6 different cases for that. Press Control E. Now I will explain what is a case structure. Okay, right click on your structures. Okay, right click on your block diagram, go to structures. Once you go to structures, you will see there is a for loop, there is a while loop. तो जिस लाइन में हमें for loop, while loop मिलता है, उसी के ठीक नीचे देखिए for loop के ठीक नीचे there is a case structure. Okay, so this is the case structure. You just drag and drop this case structure, and just like a while loop and for loop, you have to draw a rectangle like this. So it shows me a case. Okay, if you see with the question mark, contains one or more sub diagrams. It contains one or more sub diagrams or cases. So here the sub diagrams are called as cases. Exactly one of which executes when the structure executes. and the value y to the case selector determines which case to execute. You see, there is a question mark on the left. Okay, it is called as case selectors. So which type of case you want to execute? Now you see that this particular case, okay, this particular case has only two pages. One is true and one is false. You see, this is false, and this is by default a true case is on. Now I can keep a multiple cases, but I first need to decide that what sorts of operation I want to perform. Press Control E, and let's decide about the operation. Okay, for that we need to create a ring for the cases. Now that ring, right click on the front panel. If you right click on the front panel, third row, you will find a ring and enum. Ring and enum, E-N-U-M. This enum is extended numerical. In the first row itself, you find the enum, that is extended numerical. Drag and drop this extended numerical and put it somewhere. Okay, how to find this enum? Just right click. Okay, third row, you will find the ring and enum. Front panel पे right click करेंगे, third row में आपको ring and enum दिखेगा. This is the enum. You drop it and this is the enum. Okay, when you open it, there is nothing. You click it, there is nothing. Okay, now right click on this enum, right click and go to the properties. Right click on this enum, go to properties of this enum, extended numerical. Now a window will pop up. So enum, properties, data type, display format, and edit items. Edit items is very, very important. Now here we create our case. In the edit items, we create our case. Okay. So here the items are there. A value is 0. So select on the first line. Okay. And type here. Let's type here add. So item is add and value assigned is 0. Okay. Now second line automatically pop up. Write down multiply. Okay, so multiply is now assigned a value 1. Now click on the third and type, let's say, a divide. Okay, we can do a divide also. Let's divide is not a good option. Let's subtract. Okay, and fourth operation I can keep as fourth operation. I can keep it as a let's say convolution. Okay, so see that I have created a multiple cases 0, 1, 2, 3. There are 4 operations. 4 and 5 there are no cases. So select this 4 and press delete. ये केसेस कोई सा भी ऐसा केस नहीं होना चाहिए जो आपने मार्क नहीं किया है. सो ऐसा कोई खाली अगर कुछ एडिट आइटम्स में वैल्यूज 4 दिख रहा है और उसके आगे कुछ लिखा नहीं है, just delete it. So see, I am trying to do a 4 cases. Which are 4 cases? Add, multiply, subtract, and convolution. And what are the values assigned? 0, 1, 2, 3. Okay, press OK. Now see on your enum, okay, the first value is add, multiply, subtract, and convolution. So इन दोनों सिग्नल को मैं ऐड कर सकता हूँ, मल्टीप्लाई कर सकता हूँ, सब्ट्रैक्ट कर सकता हूँ, और इन दोनों सिग्नल का मैं कन्वोल्यूशन भी फाइंड आउट कर सकता हूँ. This is all I wanted to do. Okay, so that's why some space was left at the top, and I wanted to use it for enum. Okay. So see the utilization of space on the front panel. Okay. So now press Control E. Now I have created a basic function generator 1 for signal 1, basic function generator for signal 2. Okay, and then there is a case structure, and then there is an output. Yeah. add is variable or a function? See, ma'am, add addition. I don't understand your question as such. In this case, add is a function. Multiply is also a function.
Means if spelling is wrong, then in that case it will not perform like that. Subtraction
No, madam.
or multiplication, like.
No, ma'am, it's nothing. You can write anything. You can put a plus instead of add. You can write a plus instead of subtract. You can write a minus. So
Okay.
nothing. Whatever you do the programming, whatever you do inside the programming, that matters. Name can be anything.
Okay. Thank you.
Okay, so this was the case. Now see, the case structure by default has two cases: true and false. True and false. Now this is enum is generated. Now you see this enum extended numerical. Bring it on the left hand side, and see this is a case selector. This green color question mark on the left hand side. A case selector is there. You connect this case selector to this enum. Automatically see what happens to true and false. You connect it. What happens? The add becomes default. Initially true was default. So true was replaced by add. What about false? False is replaced by multiply. Okay. So true and false, initially two cases were there, but now they have become add, okay, and multiply. But I have created four cases. Just see here, add, multiply, subtract, and convolution. What about these two cases? These two cases should be reflected because it shows the last case as multiply. Move your cursor to multiply. Move your cursor to the multiply. Right click. You right click and go to add case after. You will find an add case after. Okay. Move your cursor to multiply. Go to add case after. See that the next case is subtract. Okay. Move your cursor to subtract. Again select and add case after. What are these four cases? See that add, multiply, subtract, and convolution. These four cases are now present. Okay. So now I have created a four cases. Now one by one, I will do programming for each case. So start with the add. Add means plus. Okay. So I want to add these two signals. See, now this output is outside this case structure. All my inputs, signal 1 and signal 2, are on the left side of this case structure. Okay. So space management should be like this. This doesn't make any difference if you put it on the right and this output on the left. Still we can wire it. But space management should be like this. Now add. Now what I will do one by one. I will just put the add. Okay. Now one we can do signal 1 and signal 2. We can wire it to the left walls of case. Okay. So see how I am doing now. Take a wire from signal 1 and make a tunnel across the case structure left side wall. So see a brown color, a tunnel is being made. Now take a wire from signal 2 and make a tunnel on the left wall of case structure. Done. Now take a wire from this output graph and make a tunnel on the right hand side of this key structure. It's not taking, we will see it later. Okay, it requires some output. Okay, till now only do this thing, signal 1, signal 2. Okay, now we are in which case? Check here. Is it add? If it is add, right click on the front on the block diagram, go to numeric, select and add, ADD add. You select an add, put it inside. Make sure the add should be in the add case, not in the multiply case or in the convolution or in the subtract case. Add should be in the add case only. प्लस जो साइन है वो आपका ऐड की स्ट्रक्चर में आना चाहिए. अब इसके दो वायर्स लीजिए X and Y, connect these wires to these tunnels. whatever tunnels you have made. These two signals are being added up. Okay. Now, give a wire to the output, make a tunnel over here. A tunneling is done. And now from this tunnel, give a wire to the output. Now it takes the output. See, the first case is done. First case is done. Now, you will understand the significance of case structure when we move to the second case. Second case is multiply. Now see, I already have an input tunnel wires and output tunnel wires. You see, signal 1 से एक वायर जा रहा है डायरेक्टली इस केस की लेफ्ट वॉल में, सिग्नल 2 से एक वायर जा रहा है केस की सेकंड लेफ्ट वॉल में, और यहाँ पे देखिए आउटपुट भी कनेक्टेड है. टेक अ मल्टीप्लाई, गो टू न्यूमेरिक, select a multiply. Now this is multiply. Okay, now connect it just like you have connected an add. These two wires are already there. A multiply is done. Now next, subtract. Right click, go to numeric, select a subtract. Subtract just near the add you will find. Okay, and a subtract is done. Connect this subtract to the tunnel wire. Okay. Now how to do convolution? See that in the signal processing, there is a ready-made block for the convolution. Okay. Now see how I am generating a convolution. Right click, go to signal processing. In signal processing, if you go, then there is a signal operation. Okay, so where to go? Go to signal processing. In signal processing, second row, second column is signal operation. Second row, second column is signal operation, and this signal operations gives you the first element as convolution. So see that there's a convolution, deconvolution, autocorrelation, cross correlation, autocorrelation matrix. Okay, sampling, decimated signal, multiple things are there. So there's a convolution here also. So I will select this convolution. Okay. And just drag and drop over here. This is convolution.vi. Now, what does it do? See the question mark. See that X and Y, it takes two inputs and computes the X star Y. The star actually asterisk that shows the convolution sign. So computes the convolution of input sequence X and Y, wire data to the X and Y inputs, and determine the polymorphic instance to use or manually select the instance. Okay, so I can select, connect this X to the signal 1, because what is the convolution? It's between the two signals. Now this is the Y I connected to second signal. Okay, and output X star Y is being connected to the output. Now it's done. Okay, so अगर आपका कोई सा भी केस में कोई सा भी अनवायर्ड टर्मिनल रहेगा तो ये ब्रोकन एरर हो जाएगा. जैसे सपोज अगर मैंने ये वाला वायर डिलीट किया और ये कभी भूल गया मैं, so you see automatically this wire is broken. Okay, run button wire is broken. So make sure your all wires are connected. Check all the cases. Now one by one we will check all the cases. Add, everything is wired inside the case. All two inputs and two outputs. Everything is wired. Now multiply, yes, both are wired. Subtract, that's wired. And convolution, it's wired. Okay, so that's it. Our program is done. Okay, our program is completed now. Now we want to execute this loop inside a while loop. I right click, go to structures, select a while loop, and put every program, this program inside a while loop. Okay, so this is the while loop. Now I will create a stop button because there's a run button is broken. So I move my cursor to the loop condition, right click, create a control. A stop button is being created. Okay, next thing, I want to insert some delay. So right click, go to timing, and this is wait millisecond, drag and drop, put it over there. Now move your cursor. How many milliseconds to wait? On the left hand side, right click, create a constant. You can write as 200 milliseconds. That's sufficient, I guess. So whole program, यानी कि signal 1, signal 2 और output तीनों के तीनों और ये चारों ऑपरेशन add, multiply, subtract, convolution, everything will be delayed by 200 milliseconds. Okay, that is 0.2 seconds. Because we have one loop, we have put all or complete program inside a loop, and that has a delay of 200 milliseconds. Now press Ctrl E, move to your front panel. Okay, so I have already colored the plot 0, signal 1 as green, signal 2 as blue, and let's do this coloring of third one as a red one. Increase the thickness. Okay, now let's start the program. So first we will do add. Add पे select किया, E num पे आप add select करेंगे and run the program. See two flat line signal 2 का क्या है? Oh, one more thing I forgot. One important thing I forgot. What is signal 1 and signal 2? That's I have not given as a signal type. Okay. So go to signal type of this basic function generator. पहला जो basic function generator है upside वाला. Move your cursor over there to the signal type. Right click, create a control. Okay, so it comes with a signal type 1. Now move your cursor to basic function generator VI signal type 2, create a control. So two signal types we have selected. So see, this is a signal type 1. Let's put a signal type 1. Right click. Okay, so this is a signal type 1. Let's put it over here. And this is the signal type 2. Okay, now it's visible. Okay, signal type 1 and signal type 2 both are visible. Okay. So signal type 1 can be sine, triangle, square, sawtooth, and signal type 2 can be sine, triangle, square, sawtooth. So if the program done है, add enum पे add selected है, solve it, run it. Both show flat line because frequency is 0. Increase the frequency, increase the amplitude. Okay. Just wait. Sign करना. Just wait. Okay, so now I run this program. I increase the frequency of second signal. I increase the amplitude of second signal. Now both are sine. Okay, and I'm saying some output over here. So I reduce the frequency. Try to reduce the frequency. Okay, so it shows me the addition of two sine signals. Okay, so these two sine signals are simultaneously getting added up. Suppose I keep an amplitude as 10, frequency as 10, second amplitude is also 10, and frequency is also 10. Say that a complete ramp signal I'm trying to get. Two sine signals are being added up and output is being displayed. Okay, now select the first, select about the multiply. In this case, we can take a second signal as a let's take a second signal as a square wave. Now I have selected a second signal as square, first as a sine. Now see the amplitude and frequency variation. Okay, this is a subtracted signal. Now third, just wait, there is some signal 1, signal 2. Now I try to multiply, I click subtract, so automatically the signal is getting subtracted. And if I put a convolution, just wait, I can change it to a V-form graph. Replace with a V-form graph. Yeah. And let's see that. So see, this was a difference. What mistake I made in my program? I use the output as a V-form chart. Now I replace it to a V-form graph. Because ये दोनों signal with the time they are changing, so these are charts. But output is pre-calculated. Okay, so I need to put it as a V-form graph. So all accumulated graph at one instance I can see. V-form chart भी ठीक है, लेकिन V-form chart भी time के साथ change होता रहेगा. I want an accumulated output. Okay, now see that these two signals are added up. So this is sine and square. See that how this sine and squares added up and how it looks like. I change the frequency of sine. See that. I change the frequency of square. See the structure of output. The red color is our output. This is one case. Okay. When sine and square both are added up. Okay, now next, subtraction. Next is a multiply. Now see the signal gets multiplied. The sine and square, when they gets multiplied, we get this M and W sort of shapes. Okay. If I increase the frequency of sine, see the multiplication is more towards sine. And if I increase the amplitude of square, see, this is the output we get. So multiplying are two signals. Okay, which signals? One green one is your sine, and this blue one is your square. Okay, now third case is subtract. A signal is subtracted. So this is a subtracted signal that you are observing on the output. Now increase the frequency, see the change. Okay, some different shapes you start observing. This is subtraction. Now important thing is a convolution. What happens when we convolute the sine with a square? Okay, if I do a convolution of a sine with a square, let's see the fourth option. Someone is asking, can we add a fuzzy rule based in case structure? Fuzzy rule. See, sir, a fuzzy logic system is available in the LabView. You need to install its library. Okay, so you can download it and you can use it in the case structure. Yes, you can use it in the case structure. Okay, now let's see for the convolution. See that a convolution. This is a convolution of sine and square. See how much a clear graph is there. The convolution shows the similarity between the two functions. Okay, complete two functions are swept across one another, and you see this. What happens to the convolution output if I change the frequency of a sine? And if I change the frequency, see that this is a convolution of sine and square. Now, suppose I made a convolution of two sine signals with the same frequency. This is a convolution of two sine signals. Okay, so frequency is almost 4 here. Okay, let's do a convolution of sine with a sawtooth. Sine, square, and we can do a multiple operations like a convolution. So here, if you see that sine and square, these two are very standard signals, and it gives us a very standard waveforms. As such, there is an output. So this shows the convolution output of sine and square. Both are almost at the same frequency of 2 hertz. Okay, so see that this is adding of two signals. Now this is multiplying the two signals. Now this is subtraction of two signals. Okay, and this is convolution of two signals. So basically, I have used one output for 4 different operations. So as such, my program is okay, and two signals, signal 1 and signal 2, they are being generated. So I repeat this signal 1 and signal 2 operations, and I connect it with a case structure, and the case structure gives me a very, very good output. So case structure is very, very much important. So this is how we see that in the industry. Is the one way, like a complete plant, a complete industrial plant is being controlled by one front panel. You select a case, you want to see the output of room number 1, room number 2, okay, plant 1, plant 2, plant 3, different temperature sensors, different pressure, flow readings. So all you can get when you select a extended file in the extended numerical. Okay, so this is and signal processing library is huge. We can perform any sort of operation as per our requirement, any sort of operation as per our requirement. So it's very, very important and not so difficult. Really, it's very, very easy. See that if I put a frequency of sine and square as 10 maximum, you see the convolution waveform. It's very beautiful. Okay, so this is how we can actually explore the signal processing operation for the students. Normally, we theoretically teach the convolution, cross correlation, autocorrelation like concept. But when a student has the option of changing it by themselves, the amplitude or frequency of first signal, amplitude or frequency of second signal, and they can convolute, they can do a convolution, cross correlation, related operations, then becomes very easy. So similarly, we can do an FFT, we can do a Laplace, we can find a Z transform of any discrete data. So this is how the key structure works, key structure functions. Okay, so this was the one case. So with this, I try to explain some concepts of signal programming, signal processing. Yeah. Not so difference. Okay.
There's one question.
Yes.
How to interface this LabVIEW output with the plant?
Sir, basically, the LabVIEW can be interfaced with so many data acquisition devices. DAC devices are NI products, as well as they can be a product of any third party. So if you like, and for an example, you are having a multiple sensors. They are you create a sensor networks of flow, pressure, temperature. Okay, you can give it to any output port of a DAC, and you can do a digital reading or analog reading of that data on the LabVIEW front panel. For that, you need to control your laptop. Your laptop must have a LabVIEW software. You must have a data acquisition device. In an academic case, it can be an RPi, Raspberry Pi, or it can be an Arduino board. You can have advanced boards like ARM processors or Jetson Nano NVIDIA boards. You connect it to your to a laptop, and then there are multiple read and write channels in those boards. Analog read, analog write, digital read, and digital write. You connect your sensor to those ports, and the data acquisition device is now connected to your LabVIEW. You go to Measurement and Automation Explorer. First, try to identify whether LabVIEW recognizes that hardware. Once it recognizes, we can program it. It's very easy. So from tomorrow onwards, last 2 days, we dedicate this FDP for a hardware interface only. So in that, your doubts will be more clearer, sir. Yeah. So see that this is the case. And normally what I do, what's my style of working here? If suppose, because I'm a communication engineer and I work in a lot of communication related projects. So whenever I get suppose I have 7 kilometer of fiber, I do frequency modulation scheme, and I allowed my laser signal to pass through an optical fiber. And once it is getting detected at a photodiode, I connect my photodiode to an Arduino board or a Raspberry Pi board, and then I interface it to LabVIEW, and I try to find the convolution, and I try to find an autocorrelation between these multiple signals, multiple transmission signals. So then I get an idea that exactly how my system is behaving. So changing a time domain signal to a frequency domain always gives us the benefit of analyzing a particular stability of a system. So like there are multiple projects that we can do. Okay, so this was the one case. So I try to explain with the help of signal processing. Let's move to the another case now. Go to File, New VI. Okay. Now, there is another structure. If you see that in this program, my front panel was bit messy and bit congested also. Okay, I have to make sure that I have 4 knobs and 3 charts. So 2 charts and 1 graph. And of course, there's a signal type 1, signal type 2, and enum. So as such, I don't have much space to work with. But the case structure I have created on the block diagram. That was the problem. So block diagram programming automatically becomes much more easier because I have created 4 cases over here: add, multiply, subtract, and convolution. But can I do the same thing on the front panel? So block diagram is easy with the case. I agree with that. But how I can make my front panel programming much more easier, much more space exploring. Okay, so then we can go for a next VI. Okay, and now there is an option of a tap control. I will explain a tap control. So here I will like to have multiple frequency knobs with a multiple pages. Okay, so just some operation we will perform. Now, what sorts of operation we can perform? We need to see. Suppose I wanted to have two signal operations, and that two signal operations we can let's create a one signal. Okay, so go to front panel. In the front panel, you have to go to where to go? Layout. Okay, in the front panel. So see, there is a boolean. Below the boolean, there is a list table entry, and then there is a layout. Okay, so in the layout, go and select this tab control. So boolean के नीचे list table tree है और उसके नीचे layout है और उस layout में आप tab control select करेंगे. Select that tab control. Just put it somewhere. It shows there's a page 1, page 2, and there's a tab control. Just put it like this. Okay, so this is the one signal you have created. Okay, so tab control. Now tab control, if you see that this tab control consists of page 1, page 2. Okay, so now whatever operation I wanted to perform, I can select as a page 1, page 2. Suppose there is a sign signal I will create. I want it to see. I want to see its FFT, fast Fourier transform. I will write an FFT. Okay, now this sign signal, I want to convert it to a Boolean logic. I want to convert to a digital, or let's say Boolean array. Okay, now I wanted to add a page 3, page 4, page 5 like that. So second page is a Boolean array. Now select the Boolean array, right click and go to add page after. So a third page automatically getting displayed. Now what more you can do for a sign signal? So we have done one FFT operation. We have converted a sign signal to Boolean operation. Then in the third case, what we can do, we can have a let's say, let me check what options do I have in signal processing. I can add some noise here. Okay, let's explore the noise part. Okay, let's explore the noise part of this particular thing. So there are certain noise. Which sorts of noise are there? Here we can see signal processing. In signal processing, there's a waveform generation, and we have a uniform white noise, Gaussian white noise, periodic random noise, and inverse frequency noise. So uniform, Gaussian, periodic random, and inverse frequency. I will make a 4 pages for this: uniform, Gaussian, periodic, and inverse frequency. Okay, let's write it first as a uniform noise, a Gaussian noise. This is periodic random noise, and I want to create a 4th page. Right click, add page after. So this is, you can write here, inverse frequency noise. So I have created now 4 different noises. Yeah, 4 different noises are there. Looks easy. So now there are, as such, now you can see there are 4 front panels. This one, this one, this one, this one. Now, this is a tab control. Okay, so everything I have created, the 4 pages I have created on the tab control. Just like a case structure has two by default cases, true and false. A tab control has two cases, two pages, page 1 and page 2. And then we can do a add page after like that. Now, a tab control doesn't work independently. It is dependent on the case structure. So tab control is like you can say extension of a case structure from the front panel side. Create a case structure. Now where to find a case structure? Go to structures. In the structures, you can find a case structure. Just below the for loop, you can find a case structure. Now, this case structure is being done. Okay. Now connect your tab control to this question mark, that is case selector. Now automatically see a Gaussian noise, that true becomes a uniform noise and this becomes a Gaussian noise. False becomes a Gaussian noise. Now there are other cases also. So right click on the Gaussian noise, add case after. The third case is periodic random noise, automatically generated. Right click on the periodic random noise, add case after. Fourth case is inverse frequency noise. So I have a 4 cases: uniform white noise, Gaussian noise, periodic random noise, inverse frequency noise. That's it. Okay. So I can now show the output. I can generate a one waveform and I can show the significance of these noises. Okay. So let me put it like this. Okay. Now, first I will generate a one signal. One signal I will generate. I require a waveform chart for that. So this is my signal. Okay, so this is my signal. Now I will require amplitude and frequency for this. I can create two knobs. I can write here signal amplitude. I can create another knob that shows me signal frequency. Two knobs are being created. Okay. Now suppose I generate a sine signal. That sine signal added with a uniform white noise, and how my signal looks like, that will be displayed over here. That sine signal added with a Gaussian white noise, how that signal looks like, that will be displayed here. Periodic random noise, inverse frequency noise. So I will create a 4 waveform graphs here inside this. A waveform chart we can select. I can write it here. Signal plus uniform white noise. This is chart 1. Gaussian, we can create another signal, a waveform chart. Signal plus Gaussian noise. Periodic random noise, I can create another waveform chart. Signal plus PRN. Okay, in short, I am writing periodic random noise. Inverse frequency. Oh, did I meet most? Oh, this must be moved out. This must be kept over here. Signal plus uniform, Gaussian, periodic, and inverse frequency. Waveform chart. And I will write here signal plus inverse frequency noise is IF Let's write it I and V. Frequency noise. Okay, let's give a color to each signal. Okay, so now see in the front panel itself, how many waveform charts are there? 1, 2, 3, 4. 4 for 4 cases and 1 for a common input. Okay, now one more thing. I have defined a signal amplitude. I have defined a signal frequency. I must define a noise amplitude also. So right click, select a knob, write down noise amplitude. Okay, so this programming is done from the front panel. Front panel side पे ये programming हो गया. Press Control E. Now see that I have already connected a tap control. So now I am getting a 4 cases. One by one cases I will see. Uniform noise, Gaussian noise, periodic random noise, and inverse frequency noise. Select everything and put it outside the case. One by one we will use this. Okay. Now select uniform noise. Uniform white Gaussian noise. Where you will get uniform white Gaussian noise? No, first thing we will do, we will try to create a signal. Because signal plus noise करना है तो पहले signal बनाना जरूरी है. So this is a signal amplitude. This is a signal frequency. Let's create a signal. We know how to create a signal. Right click, go to signal processing. Once you go to signal processing, select go to waveform generation. In that waveform generation, select this basic function generator. Okay, this basic function generator you will select here. Let's not select the basic function generator. We can, yeah, let's select that. No problem. If we go to waveform generation and select a basic function generator. So many options are there. So any something you have to use. A basic function generator is there. Now connect the frequency to the frequency. This is a signal frequency. Connect this to a frequency now. Amplitude to the amplitude. Connect that. Okay, this thing is done. Now next thing, signal type. Move your cursor to the signal type. Right click and create a control. It gives me a signal type. Here it's a signal type. Okay, I can have a select signal type. Now, where is the signal? So this is my signal. Give the output to the signal. Given. Okay, so one operation, the generation of signal is done. So आप front panel में से sine wave select कर सकते हैं, amplitude, frequency आप change कर सकते हैं, and then generation of signal is done. Now next thing, what we can do now, we have to work with the noise. So right click करेंगे, go to signal processing. In this signal processing, go to waveform generation. In this waveform generation, now you can see in the first 2 rows we get all the waveforms, and in the last 2 rows you see there is a uniform white Gaussian noise Okay, uniform white noise, Gaussian noise, periodic random noise, and inverse frequency noise. These different sorts of noises are there. And as a communication engineer, you must be wary of these sorts of noises because these are always present in your channel. So as a communication engineer, if you want to remove, if you want to design an optical filter, or if you want to design maybe a microwave filter, so then you must be aware of the characteristics of a particular noise, how that noise behaves, what's the range of frequency, what's the amplitude range. Okay, and then only you will be able to eliminate that particular noise by designing a certain sort of filter. Okay, so we have these 4 noises. I will just pin it. See, this is the pin function. आप V-form generation पे एक छोटा सा पिन बना हुआ है. Okay, इसको पिन कर देंगे तो आपको बार बार वो ओपन करने का जरूरत नहीं. Okay, now this is I will just drag and drop. Uniform white noise बाहर निकाल दिया, Gaussian waveform noise बाहर निकाला, PRN or inverse frequency. All 4 noises I have removed. I can. Okay, so this is uniform white noise. This is Gaussian white noise. This is periodic random noise, and this is inverse frequency noise. Okay, so सब cases के अंदर वो noise हम रखेंगे. So uniform noise, uniform white noise के अंदर uniform white noise रख दिया. Uniform white noise के अंदर uniform white noise रखेंगे. Now see its property with the question mark. What are its properties? See that there is an amplitude of this signal. Noise का amplitude कितना है? That's what it's asking. And then there is a signal out. Okay, now what you need to do? You need to add 2 signals. You need to add signal plus noise and give it to that. Okay, so what we can do here? See, this is our uniform white noise. And then Gaussian noise, put the Gaussian noise inside this. Okay, the third one is periodic noise. Put periodic noise inside this. Fourth one is inverse frequency noise. You can put it inside this. Okay, noise amplitude should be common for all the blocks. I keep it on the left. Okay, now uniform noise. So where is signal plus uniform noise? Here. Okay. This is signal plus uniform noise. Now you want to add a signal to this. How to add? This is your signal. Have a plus sign. Go to numeric, add sign. What? Yeah, this is add. Okay, take one side X input from the signal. Okay, and another will come from here. Okay, this is X is defined. Yeah. Now this is a case structure. Give a noise amplitude to this. Okay, so this is done. Okay, now whatever the output is, you need to put it with this signal plus uniform noise. There is signal plus uniform noise over here. Okay, so see that how I am doing it. Addition second input is coming from output of uniform white noise, and addition's output is going to signal plus uniform noise. Okay. Actually, I have made a mistake. I should keep it on the left-hand side. So noise on the left-hand side and signal on the right-hand side. Okay, I can rectify that mistake. I'll just wait. First, I should have created a case structure, then signal. It becomes much more easier. This is my signal. Just put it on the right-hand side. Now this is my case structure. Move it. Yeah, this is my case structure. Now it is on the left. So it looks good now. This is the case structure. This is my signal and frequency. Add signal. Connect my signal from this. One input like this. And output can be given like this. Okay, we can connect and noise amplitude like this. This is the one case. Second, Gaussian noise case. Same thing we will do. Signal का एक input यहाँ पे जा रहा है. Okay, and there is a white noise. Gaussian noise inside this. Go to periodic random noise. Now this is a periodic random noise. Amplitude, we can connect to a noise amplitude. And this input, we can connect to one input of plus and signal plus periodic random noise, we can connect like this. The last one is inverse frequency. We can give a noise density input like this. And its output to one of the input of add this gate, this add. The add output can be given to signal plus frequency. Okay, so this is all we have in our signal. So see that one signal is generated over here. This signal is added to all four cases, all noise four cases. ठीक है, so कौन-कौन से चार cases थे? Uniform noise, तो हमने उस noise का output इस plus को दिया और एक output जो addition का था वो signal से आया. Then we add to signal plus uniform noise. So Gaussian noise के साथ भी वही किया, periodic random noise के साथ भी or inverse frequency noise. We have given a one common amplitude, noise amplitude. Okay, now next thing, I can put this program inside a while loop. Okay, so we put program inside a while loop. We create a stop button, right click, create a control. We give her some timing delay. or 200 millisecond timing delay I can give. Okay, so this program is done now. There's no error also. And now let's run it. So there are four cases. A uniform white noise. We know first everything is flat because signal is flat. I increase the signal amplitude, I'll give a signal frequency. So see that now signal plus uniform white noise is actually same because noise amplitude is 0. Now let me increase the noise amplitude. Now see, how does the uniform white noise behave? So on the left, you are seeing is a sine signal with certain frequency. On the right, a page 1, that's a uniform white noise as a signal plus uniform white noise. This is how a noise looks in the channel. Now move to the second page, that is a Gaussian noise. See, this is a Gaussian noise, much more distorted. We can't identify whether the signal is sine or not. Okay, but the same amplitude, uniform noise, we can identify that it looks the sine. A Gaussian is a bit more distorted. Go to periodic random noise. See, we get a flat line. And if with the same amplitude, if I go to inverse frequency, little bit I can identify, but see the frequency is fluctuating. Okay, so uniform white noise very much similar to sine, doesn't affect much. See, the amplitude is now 6. Gaussian noise, if I reduce the amplitude, see we can find it out. Yeah, the reduced intensity, slowly we can identify the Gaussian noise. So Gaussian noise sensitivity is very poor. Periodic random noise, I reduce the noise amplitude and see the noise amplitude is almost 1, but still at almost 1, less than 1, we are getting a little bit of sinusoidal shake. Periodic random noise is very poor, and it totally affects our signal. And if we see the inverse frequency noise, the amplitude is very poor now, amplitude is very low, noise amplitude. But if I slightly increase the noise amplitude, the signal is completely destroyed. We can see the fluctuation nature of the sinusoidal signal, but see the varying frequency. So that's why it is called as an inverse frequency noise, because we never know that what frequency your sinusoidal is doing. So uniform noise is still fine. Gaussian maybe okay. It's periodic random and inverse frequency. They are very poor sorts of communication signals. So they actually damage your channel more than anything. Okay. So normally when we do a signal processing setup, so in that we, apart from adding a noise, because noise is as such present in the channel, we in the hardware setups, we don't need to add a noise. A noise is always present in the channel and we always get it as a part of our signal. Okay. So we recognize that which sort of noise it is, and then we put a filter of that particular frequency. So this is the one case. Now, next thing, all these noises are done. Press Control E. Now this is the program. One case structure for 4 different cases. Okay. Now suppose I wanted to have an FFT of this noise signal and an FFT of a particular noise signal. So what I can do here, I can create a graph over here. Select a waveform graph. Okay, not necessarily FFT. Let's select a power spectrum / power spectrum density. So all are familiar with the signal to noise ratio. Okay, so signal to noise ratio is being defined with the PS and PSD, power spectral density. So what's the power of that particular spectrum? Okay. PSD. Now, what you need to do, right click, go to signal processing. If you go to signal processing, then in the signal generation, not in the signal generation, signal operation, here also not, transforms, no, waveform condition, no. Yeah, so in the waveform measure, WFM measure, okay, so you right click, go to signal processing. In the signal processing, first row, third column is a WFM measure. In WFM measure, there is an FFT power spectrum and power spectral density. This is basically PS and PSD is find it out by FFT, fast Fourier transform. Okay, so here, how to find it? Right click, go to signal processing, go to waveform measure, first row, third column, waveform measure. And in this waveform measures, in this fourth row, FFT, power spectrum and power spectrum density. Select this. Here this time signal, connect this. Connect it to a power spectrum density. So this is for the case one. Uniform white noise पे भी बस ये आपको tunnel को connect करना. This is done. Third case is being done. Fourth case is also done. Third case done. Fourth, second is remaining. Yeah, so my arrow is now unbroken. All cases are done. Uniform white noise को भी FFT से connect कर दिया है, power spectrum density से. Gaussian noise को भी हमने connect किया है. Periodic random noise को भी और inverse frequency noise को भी. Then press Ctrl E and see. This is a PSD, power spectral density, for this particular sinusoidal signal. So this is basically an FFT, okay, fast Fourier transform. So if you find out a fast Fourier transform, this shows you a complete scale. So there are various ways to use it. Okay, this was the first case. What about uniform noise? Periodic random. See that a power spectrum density of a periodic random noise is very, very poor. And if we select an inverse frequency noise, it's also okay. You can see a one peak on the top left. If I stop it, and if I see it, page 20, you see this is a power spectral density. Okay, for uniform noise, if I run this, I stop this program and try to see. See, uniform noise gives us the very good power spectral density. Okay, even if any sort of noise is bad, but still our signal strength is not at all affected. I get a one single peak, whether the width is more. But that's not a case with the periodic random noise. If I run it, you see so many peaks. So that means my signal strength is scattered all over the frequency band. So actually my signal has some frequency. You see that this is a sine signal. What is the frequency here? The frequency is around 2 Hertz. 2 Hertz frequency, 4 volt is the amplitude. But power spectrum is like a complete time domain, complete frequency domain, this frequency is scattered. So accordingly, and suppose if I reduce the noise amplitude, you see I started getting a clear power spectral density on the left. And as I increase, then slowly, it will. So many sidebands are functioning with it. Okay, so this is like tabular functions. We have seen two certain examples. One is using a tab. So what sort of tab? Uniform, Gaussian, periodic, inverse frequency noises. And we have seen their FFT also, a power spectrum or power spectral density. So there is a one signal, then there is a signal plus noise, and then there is a FFT, or better called as a power spectral density of that signal plus noise. So you can see that in this front panel, how many graphs and charts are there? One for the signal, one for a PS-PSD, that's common. My input and PS-PSD is common. And then there is a uniform noise, Gaussian noise, periodic random noise, inverse frequency noise. There's a 4 charts. So total there are 6 displays. Okay, 6 displays. But because I have used this a tabular function, so I can have a place for a one display, and I can have a different cases. But in the case structure, you can have a multiple scenarios. So case structure reduces the programming time, space in the block diagram. The tabular actually makes a multiple front panel. So it's like these are 4 pages. We can have a 10 pages. So we can have a 10 front panels. So it totally depends. So whatever common part is there, common input is there, we keep it outside the tab control. Whatever common, so that's an input, that's a common. What is a different part is there, that we put inside the tab control. Okay, so common input, common output, that's kept separate, and all 4 things we kept it here. So yeah, this is all about the key structure and the tab structure. So this is how we make a multiple programs. Now there are certain profiles, library profiles that are remaining. One is a file IO. Someone asked me whether we can plot it in the Excel. We can store the data in the Excel. So that's possible. So file IO is the one option. And this hardware interfacing is bit remaining. So next 2 days is going to be on that only. So basic the applications of the Labview for your real life setup. So over to you, Deepak sir. Some doubts or problems are there, then I'm
Participants, if you have any doubt, please ask. Sir, I guess there are no doubts.
okay, sir.
So thank you so much, sir, for a wonderful session. We all learned a lot from this session, and we'll be using this knowledge for our future work.
Yes, sir. Thank
Thank
you.
you so much, sir. Sir, should we end this meeting now?
Yes, sir. We can end the session, and then next 2 days, we do with a more meaningful hardware interface and other related programming stuffs, applications of this particular part. So yeah,
Okay, sir. Thank you. Thank you so much.
Thanks, sir.
Yeah.